All right, here's our video today, the Hubble constant and the expansion of the universe. And the questions I always get, and the questions a lot of people get, professors, teachers, is if the universe is expanding, well, what is it expanding into? Right, but the thing is it's not expanding into anything. And that's really hard to wrap your head around. Unless, of course, we are missing something, right? So, as of now, what we know now in physics, it's not expanding into anything. You have to think of it as existence expanding. So anyway, the Hubble constant, and we can go into philosophical questions on this also, and multiverses and everything like that. But let's just stick with the Hubble constant itself. So the Hubble constant, and we'll write it over here. We should have our pen ready. And maybe we'll use yellow, bring it out. So it's written like this: H with a subscript O. And it's not helium, right? No, that's the Hubble constant. And right now, it's around, so we'll use approximate. It's approximately 67.4 kilometers per second per megaparsec. Forget that M right in there. Megaparsec. Right? So that's the rate of the Hubble constant. And whether it was constant, whether it was that number in the past, that's another story in itself. When Edwin Hubble discovered this, when he looked at this over 100 years ago, he pictured the constant at 500 kilometers per second per megaparsec. And by the way, you should know what megaparsec is. A parsec, right here, a parsec. Parsec is about 3 light years. Just giving you about. So it's about 3 light years. How long light will travel in three years, which would be roughly around 18 trillion miles. But a megaparsec would be 1,000,000 parsecs. Just to give you that little reference there. And so if you think about the Triangulum galaxy, our second closest galaxy besides Andromeda, that's 3 megaparsecs away. So it's extremely far distance. So if you think about Andromeda is 2.5 megaparsecs away. All right. And here's a Triangulum galaxy. Let's write it down. Or second closest, like I said, right? Triangulum. And the reason why they call it Triangulum is it's in a constellation in our galaxy. And I'll show you that picture. It has nothing to do with it looking like a triangle, but the constellation itself looks like a triangle, and that's in our galaxy. Remember, the Triangulum galaxy is not in our galaxy. It's 3 megaparsecs away. And there it is. There's the constellation Triangulum in our galaxy. You can see Andromeda in our galaxy. You can see it looks like some milk spilled out in the galaxy. So again, if you look up in the sky and you see this kind of a triangle in this constellation, the Triangulum galaxy is scattered in there. It's not as easy to see as Andromeda because Andromeda is much closer, and Andromeda is getting closer. It's approaching us. All right, so what does this all mean? Let's do some math here, easy math. So we know that the Hubble constant, remember, it's H, the subscript O, the Hubble constant. And we're not sure if it was always a constant in the past, or it will be in the future. We're not sure about that yet. So we're saying it's around 67.4 kilometers per, that's the per sign, per second, per megaparsec. All right, so what does that mean? So let's just say, for example, we had 2 galaxies. Let's just make 2 galaxies up. And what this will give us, it's going to give us something called the recessive velocity. So we'll say recession, not recessive. recession velocity. Let's get it right today. And all that means is basically what's happening is the expansion of space becomes more significant over larger distances. So there's this apparent velocity that we're seeing of these distant objects. This space is expanding, and it seems like these galaxies are moving, but it's the apparent velocity of these galaxies. So if we had galaxy, well, what should we call it? We'll have galaxy over here. We'll call it galaxy alpha. Why not? And let's say galaxy alpha is 100 megaparsecs away. We'll put the word mega. And then we'll have another galaxy over here. Maybe we'll call it galaxy gamma. Right, and let's say that's 200 megaparsecs away. So we have our two galaxies away. And we can measure the recessive velocity, the apparent velocity of these two galaxies from our position. Okay, and let's see if we have room here. So what we need to know is we're going to take what the Hubble constant is. Take the Hubble constant. Right, and we're going to multiply the Hubble constant by the amount of the distance away, right? The distance away it is. So let's try that. All right, let's change the color so we can see the math here. So remember I said it's easy math. So the Hubble constant we said is 67.4 kilometers per second per megaparsec. And we're going to times it by the distance away that we're seeing galaxy alpha, just times it by 100, right? So we're just moving it 100, right? So well, it's not fitting in there, but we'll put it over here. 6,740 is the recessive velocity of galaxy alpha, kilometers per second. So galaxy alpha from us is moving away. It's apparently moving away from us, if there was such a thing as galaxy alpha, 6,740 kilometers per second. Whereas galaxy gamma, you do the same math now. You're doing 67.4, but this time you're timesing by 200 because it's 200 megaparsecs away. And it's just doing the math, right? So that's 13,410 kilometers per second. So let's look at a real life one. Let's pick a galaxy. We talked about the Triangulum galaxy, so let's do that. Let's clear this up, and we'll talk about the Triangulum galaxy. I'll write Triangulum over here. And we said the Triangulum galaxy was 3 megaparsecs away. So again, we use the Hubble constant times the distance, and that'll give us kilometers per second. That's the apparent velocity of the Triangulum galaxy. So what did you get? And if you want to pause the tape. So again, the Hubble constant is 67.4. And you could round it also if you wanted to, 67.4. And the distance away the Triangulum galaxy is 3 megaparsecs. So what'd you get? You got 202.2 kilometers per second. So just looking at that math, there'll be a point in time as the universe keeps expanding, is eventually we won't see the Triangulum galaxy. Or we won't see any galaxy, for that matter, unless it's coming toward us like Andromeda. So the estimate is probably within 48 billion years, we probably won't see the Triangulum galaxy in the sky anymore. So if you're doing something in 48 billion years and you realize the Triangulum galaxy, you can't see it anymore, now you know why. You can look back at this video 48 billion years ago. All right, that's our video today.